Hi everyone, here's a hopefully quick little video on how to sketch a quadratic function and how to try and get the easy marks that are related to a quadratic function. So the first thing I would say when sketching a quadratic function is to ensure that you include the basic graphing conventions. If you miss one of them, you're sure to lose a mark, so let's go through them. To start with, you want to make sure that you have the axes drawn and labeled x and y. So we're working on a Cartesian plane, it's best to draw one. And to make sure that there's some sort of scale on the axes. Now, the scale can be marked on after the curve, but there should be some numbers on the axes to indicate the scale that you're drawing to. The next one is to make sure that there's arrows on the axes and arrows on the graph that you're going to draw. Now the next part actually requires drawing the graph, and you need to know some features of the graph in order to draw it to display the curve on your axes. So some typical features of the graph are the turning point, this point here, the y-intercept, this point here, the line of symmetry, this line here, upon which the graph is symmetrical about, the x-intercepts, these 2 points here, and showing at least 3 points on the curve. So on this one we're showing the y-intercept, the turning point, and we should really show a third point, and typically it would be this point over here at 2, -1, because it's symmetrical about the axis, an easy one to draw. Now, depending on how the function is given to you will depend on what you would show on the graph and how you would calculate it. So we'll start with a standard form equation, and the order that I would do for most cases is listed over here. So I would start by finding the line of symmetry by taking the b and the a value and substituting it into this equation. Once I have the line of symmetry, I would substitute that into the value back into the equation to get the corresponding y value for it, and that'll give us the turning point. I'll then find the y-intercept by taking c and placing it next to 0. I'll determine the nature of the curve by looking at a, and if it's greater than 0 the function's concave up, if it's less than 0 it's concave down. And then I would look for a symmetrical point to give me my third point on the curve. So similar to here, I know that from here to here is 1, so if I go across another 1, I would get my next point. I've got an example of doing it here. It's actually a lot easier in practice than it is to explain. And the hint I've given you over here is that it's usually easier to draw the curve before you mark the y-intercept in. So let me show you what I mean and how to do it. I'd start with the function here, and I'd find the value of a and b. And in fact c as well, because we're going to need it in a minute. So here's c. C is equal to 2. Once I know those three values, the coefficient of x squared, which in this case is 1, is a. The coefficient of x is 3, which is b. And the constant is c, which is 2. I use a and b to find the line of symmetry, which I haven't marked on here, so I'll do that now. It's right here. To find that line, x equals -1.5 or x equals -3/2. It's the same thing. Substitute a and b into the equation -b on 2a, which I've set up here. Given that b is 3, given that b is 3, negative b is -3, which I've written up here, and we put 2a underneath. 2 times 1 is 2, which gives us -1.5. To find the y value of our turning point, now that we've got the x value, we substitute it into this equation, which is what I've done here. 3/2 squared is 9/4. Negative times negative becomes positive. 3 times -3/2 is -9/2, and our constant is +2 that we add on the end. Simplifying this, put it all over 4, and you'll find that the answer is -1/4, which gives us our turning point, which is right here. Once we've done that, substitute 0 into this equation to find out where the y-intercept is. It's always going to be c, which in this case is 2. There it is there. Because a is 1, it's greater than 0, we're going to have a concave up function. It's going to be upwards, like a bowl. Now, once I've done that, I'll try and draw a smooth curve. And if I go -1 across 1.5 across this way, if I go another -1.5, I know that that's also going to pass through too, because the function is symmetrical. It's usually at this point that I would, once I've drawn the function in, then I'd put the 2 on. Saves me trying to draw it and always missing this point. Especially with a stylus, it's really difficult to get a smooth curve. So there's my first example. Now, if it's in factored form, and I've used a really basic form of factored form in this case, where it's got x here with no coefficient, x here with no coefficient, and a value of 1 outside, a good order to do it is this, is to find the features of it, find the x-intercepts first, then the line of symmetry, then the turning point, then the y-intercept, then the nature of the curve. To find the x-intercepts, it's just going to be h and k, which is what I've done here. To find the line of symmetry, find the midpoint between h and k, which is just h plus k divided by 2. Substitute that midpoint into the function. You'll get this value here, which will give you your turning point. The y-intercept is just going to be h times k. Put that in here. The value in the front in this case is always 1, which is greater than 0, indicating the function is concave up. If it was negative, the function would be concave down. So again, I've done an example. A in this case is 1, the value outside the bracket. This is negative h, so h will be the negative of that, which is in this case is -2. K is the negative of this, which in this case is 3, and as I said earlier, a is 1. Just by looking at this, we can instantly find the x-intercepts. It's just -2 and 3. There they are there. The line of symmetry is midway between the two of them. Add them together, you get 1 divided by 2 as a half. Then I can sketch in the line of symmetry. If I substitute the line of symmetry back into the equation, it will give me the y value of the turning point. So here I've substituted in a half. That's given me -6 1/4. I can now plot the turning point. Once I've got the turning point and the two x-intercepts, it's quite easy to sketch in the curve. And if I want to, I can label the y-intercept, and I calculated it here by subbing 0 or by just multiplying h and k, which gave me -6, and you can see that -6 is about right. And we know that a is greater than 0, so it's going to be concave up. There's a quick outline of how to draw a graph for factored form and standard form. I hope that was helpful. Thank you.